Good evening everyone. Myself Yuvraj. Today I am going to discuss about the geothermal power plant. Coming to the introduction, geothermal power taps into the Earth's natural heat to generate electricity, offering a renewable and sustainable energy option. It minimizes environmental impact and is crucial in the global transition towards cleaner energy resources. Here we see how the geothermal power works. Geothermal power plants use hot water or steam from underground to spin turbines, generating the electricity. This heat is from the Earth's molten core. After use, the water or steam is returned underground, completing the cycle. This renewable energy source is viable in regions with accessible geothermal heat close to the surface. Coming to the advantages of the geothermal power. First of all, renewable and sustainable. Geothermal energy comes from the heat stored beneath the Earth's surfaces. This heat is continuously produced by the decay of radioactive materials in the Earth's core, which means it can be replenished over time. Unlike the fossil fuels, which are finite and non-renewable, geothermal energy can be harnessed indefinitely without depleting its source. This makes it a sustainable power source because it can meet from current energy needs without compromising the ability of future generations to meet their own needs. Environmentally friendly. Geothermal power plants have a small environmental footprint compared to many other forms of the energy generation. They don't require large-scale mining or drilling operations like those needed for the fossil fuels, which can disrupt ecosystem and the landscapes. Additionally, the geothermal power plants produce very low greenhouse gas emissions during the operation, unlike coal or natural gas plants, which releases significant amount of carbon dioxide and the other pollutants into the atmosphere. Geothermal plants emits minimal greenhouse gases. This makes geothermal energy a clean and environmental friendly alternative to the fossil fuels, helping to mitigate climate change and reduce air pollution. And the third one, environmental friendly. That means the repeated for the emphasis. This line reiterates the point that geothermal power plants have a small environmental footprint and produce very low greenhouse gas emissions. It emphasizes the environmental benefits of geothermal energy, highlighting its role in promoting sustainability and reducing environmental harm compared to traditional fossil fuel based energy resources. Types of the geothermal power plants. First of all, dry steam plants. These plants tap into reservoirs of steam deep within the earth. The steam is directly piped to the turbines, where it expands and drives the turbines to generate electricity. It's the most straightforward method as it doesn't require additional steps to separate steam from the water. Secondly, flash steam plants. In these plants, high-pressure geothermal fluid is brought up from the underground reservoirs. As the fluid reaches the surface, the pressure drops suddenly, causing some of the water to flash into steam. The steam is then separated from the remaining fluid and used to power turbines, generating the electricity. And the third one, binary cycle plants. These plants utilizes a secondary fluid with a lower boiling point than water, such as isobutane or pentane. Geothermal fluid is passed through a heat exchanger, transferring its heat to the secondary fluid, causing it to boil and produce vapor. The vapor then drives turbines to generate the electricity. This method is efficient for lower temperature geothermal resources, where direct steam or flash steam methods may not be feasible. Geothermal power plant components. Certainly, a geothermal power plant typically comprises essential components that collaborate to convert the Earth's internal heat into the electricity. The process begins with a geothermal wall, drilled deeply into the Earth's crust to access hot water or steam. This fluid is then transported to the power plant. Inside the plant, the fluid's energy is used to spin a steam turbine which subsequently drives a generator to produce the electricity. Additionally, there is a cooling system in place to manage excess heat, along with various auxiliary equipment to support the plant's operations. The geothermal well is drilled deep into the Earth's crust to access the hot water or the steam. This fluid is then piped to the power plant. Geothermal power plant site collection. Here we see the geothermal power plant site collection critical factors. Tectonic plate activity. Plants are often located near active plate boundaries where geothermal sources are more abundant. Proximity to heat source. Sites need to be close to the reliable high temperature geothermal sources like volcanic regions or deep geological conditions. The chosen site must have suitable rock formations, porosity and permeability for efficient extraction and utilization of the geothermal energy. Access to the water. A steady water supply is necessary of cooling and other operational needs, making proximity to a water source essential. These factors collectively ensure the efficient harnessing of geothermal energy for the electricity generation. The environmental impact of geothermal power is relatively low due to the several factors. First of all, the low emissions. Geothermal plants produce significantly fewer emissions compared to fossil fuel plants, contributing to cleaner air quality. Secondly, the minimal water uses. These plants utilizes the closed loop systems, recycling and reusing the water, thus reducing strain on local water resources. Small and land footprint. Geothermal plants require relatively small land areas compared to other renewable energy sources, minimizing disruption to the environment. Limited wildlife impact. Geothermal plants are designed with minimal impact of local wildlife and the ecosystems, helping to preserve natural habitats. Overall, a geothermal power offers a sustainable and eco-friendly energy alternative with minimal environmental consequences. The future of geothermal power is promising due to the technological advancements, enhanced resource exploration, integration with renewable energy sources, direct use applications, support to government policies, and its low environmental impact. Geothermal energy is expected to play a significant role in achieving carbon reduction targets and transitioning to a more sustainable energy future in the world. Conclusion. In the conclusion, geothermal power offers a promising renewable energy solution for our sustainable future. By tapping into the Earth's natural heat, geothermal power plants can provide reliable and clean electricity with the minimal environmental impact. As the technology advances and costs decrease, geothermal energy adoption is expected to rise substantially. Its potential for baseload power generation and the integration with other renewables can diversify our energy mix and contribute to a more sustainable energy landscape in the world. For exploring the promising potential of geothermal power with us. This renewable energy source offers a cleaner and more sustainable option to meet our increasing energy demands. Its exciting prospects underscores the importance of the embracing innovative solutions as we strive for a green future, ways to meet our growing energy needs.